Hello and welcome to the NASA TechRise Student Challenge virtual event. Just last week, NASA announced a brand new challenge, which is going to start accepting entries next school year, where students are going to be able to get hands-on designing flight experiments for either a suborbital rocket with microgravity time or at a high-altitude balloon with ability to sense the atmosphere and have line of sight down to Earth for imaging.
What we're really excited about with this challenge is we're giving students access to those same types of environments and those same NASA-sponsored commercial flights that we use for our technology development and demonstration. There's three flight providers who are providing flights for this challenge. So Raven Aerostar will be providing their high altitude balloon. It's a zero pressure balloon. It'll give about 4 hours of flight time at 70,000 feet. And during that time, the experiment will have exposure to the upper atmosphere, views of Earth, perhaps if you can look around the balloon, views of space. Up Aerospace and Blue Origin will be providing suborbital rockets. Those are the Up Aerospace Spaceloft XL and the Blue Origin New Shepard. Those flights will take experiments just past the edge of space. They'll experience about 3 minutes of microgravity, or zero G, as is often said, weightlessness.
So we've got 4 inches by 4 inches by 8 inches, and try to think like, how much can you really pack into this? And what some of you might not know is that NASA is flying satellites half this size all around you all the time right now, and they pack a lot of punch. There's great things that come in small packages in spaceflight. Go to the challenge page. There are tech sheets for each of the vehicles. It tells you some of the specs and the limitations of what we have. So this challenge is open for U.S. schools. It's open for students attending 6th to 12th grade at U.S. public, private, and charter schools. We need a team that has at least 4 students. There's no max. You can have as many as you want, but we need to have at least 4, and there needs to be 1 teacher or adult employee of the school attached to the team. The first step is putting in a proposal. You don't need to have ever flown anything before. You don't need to have ever coded before or done electronics before. You need to have that good idea, and you need to use our template, which we are going to be launching later this summer. Put in your experiment idea, upload it to our site, and that's how it all begins. And if you're selected, then you get the money and the funding and the assigned spot to go and build that experiment. We are excited that there are going to be 57 schools that are going to be selected to fly their experiments. And so as a winner, you're going to receive $1,500. You're also going to get a welcome kit inclusive of a flight box to build your experiment, and you're going to get an assigned spot to test your experiment on the vehicle that you submitted with your proposal. So either that suborbital rocket or that high altitude balloon. And these are NASA supported commercial suborbital flights.
Today I'm going to show you a quick demonstration where we're going to see how this little Circuit Playground Express microcontroller can be programmed with CircuitPython and can help teachers support students who want to create science experiments that fly to the edge of space. Let's imagine that a group of students want to explore how confetti behaves in microgravity for a party in space. Hopefully on the left right here you can see my experiment in its box. And you can see the green LEDs flashing. That's my go signal. That's telling me that this is ready to go. And then down here on the bottom right, I have a serial monitor, which is really just a way for the microcontroller to tell me what it sees. And when I press play here, it's going to take us through a simulated rocket flight. So here we are. We have liftoff. We have red lights flashing inside of the box randomly here, telling us that the engines are burning. And we are headed for space. In just a moment, we'll have main engine cutoff, and then separation, which is when the capsule becomes separate from the rocket booster. And now we're in microgravity, and in just a moment, we're going to hit apogee of the flight, right about there. And there comes the confetti blowing around inside the box. And we're now on the downswing here. We're headed back to Earth. And in just a minute, we're going to close up the hatch there and head back down to the ground. And in just a moment, we'll see parachutes deploy. We'll see some blue lights that tell us that we're floating back to Earth, and the experiment will end. So the whole point here is that this simulator will help you, along with support from future engineers, to to really develop these experiments and test them and know that they're going to work on the ground before you ever get them into the rocket. And it's going to let you develop something that really works, and it's going to help you learn a lot in the process.
If this seems completely bananas, if this is just like, this is so complicated, I just want to emphasize to you, you don't even have to have touched a line of code to put in a proposal idea. And we encourage you to go to our educator workshops. You can go to the Future Engineers page and sign up for those. But you really just need to put in that proposal, put in that idea, and we have dedicated team for those teams that win. We have dedicated staff that are there to have office hours and to do sessions and to do education workshops to help you guys take your students and turn that idea into reality. How do you start with your students?
Well, how do we start? I start by, piquing my students' interest, asking different questions, you like space? What do you like about space? What projects can we look at in order to, explore? How can we learn a little bit more about the natural world around us? So from there, we research and then we go into different aspects of learning.
The things going on around you in everyday life, how do they change when you go into space flight?
Our best estimate on landing day that we thought we could get to was around 45 meters. What actually happened on landing day was that we picked a target and we got to within 5 meters of that targeted spot on the surface of Mars.
It all started with a flight, right? So you gotta start small to dream big. And
you gotta start small, absolutely.
I never dreamed I could be an astronaut. I just wanted to fly jets when I was little, and I love math and engineering, but it's because of great teachers like all of you that instilled that in me when I was young, and it allowed me to have an awesome career and reach my dreams.
Given my background and where I came from, it's mind-boggling that I could eventually end up here where I am today. There was little opportunity where I grew up. Educational programs to learn outside the classroom were few. But thanks to teachers who inspired and guided me, particularly math and science teachers, I ended up studying engineering and started on a path to a successful career in STEM. To do our work in STEM engagement at NASA, we know that in so many ways, our success depends on you, dedicated teachers and educators. Our hope is that you will share TechRise broadly with your students and colleagues. And I'd like to encourage you all to join us again in July or August for one of 2 NASA TechRise Educator Summer Workshops, during which we will dive into the basics of electronics, coding, and designing for flight. For more information, visit futureengineers.org/NASA TechRise.